When we talk about rational exponents, we really mean fractional, right? Because a ratio is a fraction, so we sometimes refer to these as fractional exponents as well, right? It's something like this, 4 to the 3 halves, for example. This is what we mean when we have a rational or fractional exponent. And there's a couple rules on how to deal with these, or even more like a definition of what this means. So let's start with the first definition. A to the power of 1 over n, what that means is the nth root of a. Okay, so it's just these square roots and cubed roots and all these become so cumbersome to work with that when we bring it into this exponential notation, then A, it's more compact, and B, we can use all of our rules of exponents to simplify these when they get a little more complicated. So let's look at a couple of examples. For instance, we may have 64 to the power of 1/3. Okay, well, just while we're still getting used to this, let's rewrite it in radical form. This is the cubed root of 64, right? Because it's 1/3 is the cubed root. What's the cubed root of 64? Well, it's 4. You should start having an intuitive feel to what the basic cubes are. For instance, 2 to the cubed, 2 cubed is 8. 3 cubed, 27. 4 cubed, 64. 5 cubed, 125, right? I won't go up to 6 cubed, but these you should be able to recognize. That makes it easier when you need something like the cubed root of 64. You can automatically know that that's 4. Okay, let's try another one here. 1 over 64 to the 1/2. Okay, well this is simply the square root of 1 over 64. Well, 1/8. Right? And so on, right? We can keep going through these, and we will. How about this one? Let's do negative 64 to the 1/2. Okay, versus, I'm going to do 2 for the price of 1 here. Negative 64 in parentheses to the 1/2. Okay, what this first one is, with a negative out front here, this is simply negative square root of 64, which is negative 8. Okay, but then with the square root inside the parentheses for square root of negative 64 is what this is. Negative 64, this is, well, I'm not even going to say equals, this is not a real number. If you've already been introduced to complex numbers, you could write that as 8i. So it depends whether or not you've had complex numbers or not. Where this section appears, we're assuming we haven't seen complex numbers, so we'll say not a real number. Let's kick it up a notch. A generalization of the rule that we've been using is this. We have a to the m over n power equals, okay, so what this is the nth root of a all to the power of m. So this m up here becomes the exponent, so I'll put a little caret there, that's our power symbol, and this n becomes the radical. Right? It's always the one on the top, exponent, the one on the bottom, the radical. You could write this another way. It's a little bit harder to work with, but it's equally valid. You could write this as the nth root of a to the m. That will also get you the correct answer. It's just usually a little harder, so I just recommend taking the radical first and then raising it to the power. Let's look at some examples. How about 4 to the power of 5/2? Okay, well, that tells us that 5 is our exponent, 2 is our square root, or our root, in this case it is the square root. So let's do the square root first, square root of 4 all to the 5th. And I'll show you the other way just to show why this way is easier. First we're going to do the square root of 4, which is 2. Okay, so this is 2 to the 5th. Then 2 to the 5th is 32. We could have also done the exponent first and then the radical. I'll show you how that's a little bit harder. Here we go, equals, okay, so now we're doing the square root of 4 to the 5th. Well, what in the world is 4 to the 5th? I have to break out my calculator. 1024. Square root of 10,024. Okay, now we have a new problem. What's the square root of 1024? Okay, back to the calculator. Okay, 32. 32. Okay, so note that this method gets us to the same answer, but it's a much harder way to get there. Let's try -8 to the 4/3. Quantity, let's do that in parentheses. -8 to the 4/3. Okay, so we do the radical first, cubed root of -8, all raised to the power of 4. Now you may be saying, oh, we can't do the radical of a negative. Well, we can because 3 is odd. Remember, it's just evens that we can't take the radicals of a negative. Odd, it doesn't make any difference. The radical or the negative is just fine in there. So the cubed root of -8 is -2, and now we have that raised to the 4th. Well, now we're raising a negative to an even power, so the negative will go away, and 2 to the 4th is 16. And let's try one more. Let's do -9 all to the power of 3/2. Okay, well, we'll do the radical first, square root of -9 to the power of 3. But now we're taking the square root, an even root of a negative, so this whole thing is not real. Or if you have imaginary numbers, you could write this as I and go from there.